Hello. So in this module, we are going to learn about how to create positive half-wave rectifiers and the negative half-wave rectifiers. So what you do, you have a spice circuit simulator, you open it, and then on the schematic, you just have click the new schematic. So I already have this one. And with that, you then go to the component library. For example, here, you can click right here and then look for a diode, because for the rectifier you will need a diode. So just click here and then put Control R on your keyboard and place it somewhere, and then press escape button on the keypad of your laptop or computer. Then you again hit the component or press F2 from your computer keyboard, and then you write voltage, and then just put it on the screen. Then again press escape button. Then you need a ground symbol. That is how you will that. Then you would need a resistor, because let me click here. You see that there is a resistor, and once that is done, you can see that. After that, you click the wire or press F3, then connect your voltage source to the diode, then connect your diode terminal to the resistor, then connect the negative terminal of the voltage source to the ground, and then connect R to the ground. After that, press space bar to keep the schematic there and visible on your screen. Okay, now with this done, the next step is to input some parameters. So take your mouse on the screen and highlight or take it over the voltage source, right click, and it asks you to provide the input value, DC value or series resistance. Rather, just click advanced, and you want to use a sinusoidal voltage source. So keep the DC voltage, DC offset 0, amplitude, let's say 10 millivolt, frequency, let's say 1 kilohertz, and then delay just 0, or just leave it blank. That's the parameter of your AC. So you're applying a sine wave of 10 millivolt peak with a frequency of 1 kilohertz to this diode. Right click the diode. It is simple diode model, or you can pick new model, choose a particular diode if you want, and Spice will take the diode model for that. Then resistor is about, let's say, put the value about, let's say, 1K, and that's your load actually across which you will measure the output. So after that, you can just click save, and then you want to run the analysis. So this circuit, I will show you how it will behave as a positive half-wave rectifier. So it will just pass during the positive half cycle, the diode gets forward bias, and it acts as a short circuit or low impedance node, and your signal appears across the load resistance RL or R1. Just write the name here, right click here, say this is your load RL. And then during a negative half cycle, diode acts as a very high impedance uh, socket, or it acts as an open circuit, and you don't have a negative half cycle of the input passing or appearing across the load. That's why your output doesn't really have any value or magnitude. It is 0, and the voltage appears across the diode. We'll see that in a moment. So what you do, you just click the simulate, then edit simulation command, stop time. You need to run a transient analysis. So let's say you have a frequency of 1 kilohertz, that is the bandwidth of your input signal. So put the stop time about 10 milliseconds, start time to start saving data from 0 seconds, click OK, and rest parameters. So keep it here, for example. Now you press escape. No, I haven't put that. So again, go to simulate, edit simulation command, then type 10 millisecond, and then start 0. Then click OK, put it on the screen. Then that's it. Once that is done, just click run and you will see that your waveform window has appeared. So now tile the windows so that you have schematic and now take you are on the schematic window, you see the red probe appear. So with your mouse or your keypad button, click on the input. So that's your sinusoidal input waveform with a peak value of 10 millivolt or 20 millivolt peak to peak. And you want to have a voltage across the load. So you don't really have any voltage right here. So where is the output voltage? Why is it not appearing across the load? So that's the question. Or rather, you want to right click on the waveform, add plot pan, and then take this right here on the screen. So you see that your output is quite disturbed here because it's just 700 nano volt appearing. So there is something wrong we need to understand with this diode. So let me check that. So you see here, we don't have any output signal because the input voltage is less than the cut-in voltage of the diode, which is about 0.6 or 0.7 volt. So why not just increase the amplitude to, let's say, 700 millivolt, because that's the cut-in voltage for a silicon diode. So with that, if we save and then click run, we are now able to see our output appearing. So for a positive half cycle, input is 700 millivolt and your output comes out to be 100 millivolt. So why not just increase that to, let's say, 1 volt, for example, because that's how, and then click again. And now you see for 1 volt, you have like output voltage is about 350 or maybe 368 millivolt. Also about 720 millivolt is the voltage across the diode. Okay, because it is when it is forward bias, you will see that that is the voltage across the diode. So we can actually see that how much voltage is being dropped across the diode D. So what you do is take right click on the waveform and add plot pane, and then right click again, add trace, and now you want to know the voltage drop potential difference across this diode. So one is the nets, you need to select the net. So we don't know what this node voltage is, 001 and 002. So the better idea is to do one thing, right click this net, highlight it, again right click it and label it. So just we know that that is your output. So take it, select output and just say write out, and that is your port. So okay, let me just label it again. So select out and write here OUT, and with that here. So move it and place it somewhere so you can actually see that, and then select the wire and connect it to the output terminal. Now similarly here on the input, right click, highlight it. So you want to label this net. Why not just right click and click label net? This is your input. So we know that this is our input. So just say this is V in, and V in is the, excuse me. So V in is here, and then you again connect the wire to these terminals. So V in, and that's it. So now when you will simulate and you want to plot any net voltage on the net or current through the net or current through the component, you will be able to pick up and select the nets. So why not run the simulation again? And now you can just plot input, plot output. Output is on the same pane now. So you see now the input is 1 volt and the output is about 340 millivolts. So rest of the voltage during the positive half comes across the diode. So why not just click on the waveform window, right click, click add trace and select the V out first, then expressions to add, put a minus, then select V in. So that is going to be a drop across your diode. So here exactly you see during the positive half cycle, your diode has a drop of about minus 600 something, minus 600 something, because the rest of the diode, right? So just click zoom to fit. Here also zoom to fit, and you have this. During negative half cycle, you see the blue one, the output is 0 because diode is open circuit, and all the voltage is appearing across your diode, that is the V out minus V in, right, across the diode. So this is how your positive half cycle actually works. Positive half-wave rectifier actually works. Okay. Now, what if you want to create the negative half-wave rectifier? So what we'll do is just come on the schematic, then use the cut button, click here, cut it, click here, cut it, then select the right click on the diode. Oh, you have this diode. Then what you do is that click edit and then click move actually. So this is your diode, and then you with the mouse or your finger on your keypad on your laptop or computer, you can actually move it. Then press Control R, press 2 times, so you have reversed the polarity or direction of the diode. Make the connections with the wire again like before, right here, and that's it. You have got your circuit. Press escape button on the keyboard. Now you are done. Now press run. So your waveform appears again. You now see you have a clean sinusoidal input signal as an input, then press output. Now during the negative half cycle, your diode conducts the current, and during the positive half cycle, it acts as an open circuit. Similarly, on the same plot, you want to plot add trace and voltage across the diode. So V out minus V in would be your voltage drop across the diode. So you see during the positive half cycle, diode is open, so all voltage comes across it. Of course, the polarity is reversed to what we see. During the when the diode conducts current during the negative half, the red one shows it has a forward voltage drop of 0.7 volt, and the other remaining 0.3 volt comes across the load. So that's how your rectifier is operating. Okay, why not see some other exploration? Add plot pane, and here click here, then add trace, and you see you can plot the current through the load. You can plot the current supplied by the source. So you can also plot the current through the diode. So let us select these three, ID3. So here is your ID3, IR1, IV1, and IR1, right? So just maybe you have to delete this twice and your remaining currents are there. So this is how you can actually design, analyze in a simple way the diode rectified circuit. So in this loop, actually, you can apply the KVL. You can apply the KVL here in this loop, right here, and analyze the circuit. Okay, so you see that during the positive half cycle and during the negative half cycle, how the AC is converted to the DC. So it's basically you are creating a DC level out of AC signal. So hope you like this video. You understood how to analyze the simple diode rectified circuits or converter circuits, and how to use and analyze them using SPICE, how to understand the time domain analysis, etc., how to run simulations. So do like the video, comment on it, and share with others for a wider reach. subscribe to the channel and stay tuned for more informative and technically rich content. Wish you happy learning.